This section is a review of things that we will need to use throughout the course, different techniques of solving, and then business fundamentals, the identities for profit, revenue, cost, that we will also use throughout the course. First, a linear equation. How do I know it's linear? Because there aren't any exponents on the variables and there's no variables in the denominator. This has two different variables, and specifically I'm told to solve for y. So I want to get the y by itself. First subtract 5x from both sides. So 4y would be 3 minus 5x, and then divide by 4. You can either divide the entire right side by 4, or you can divide each term individually by 4. So y would be 3/4, take away 5x over 4. Now just note that if I had decided to divide the entire side, divide by 4, divide the whole side by 4, y would be 3 minus 5x, whole thing over 4. The software will take either one of those. Okay, it will be able to read that those are the same thing. Okay, next, solving with a squared. This is a quadratic equation. For quadratic equations, there are two ways to solve, but either way, they both need to have a 0 on the other side of the equal sign. So either using factoring or using the quadratic formula, you have to begin with a 0. This particular problem is factorable, so I'm going to choose to solve it by factoring. It would be an x and an x, and 24 would be, to multiply to 24, add up to 10 would be a 12 and a 2, a negative 12 and a positive 2. And then you can set each factor individually to 0. Solving for the first factor would give x equals 12. Setting the second factor equal to 0. Subtract 2 from both sides, that would give x is negative 2. So for an x squared equation, chances are you'll have two different answers. If this is a business problem, then the negative answer wouldn't make any sense usually. But if it's just a generic algebra problem, then you include both answers, and in WebAssign you would put them in either order, but you just separate them with a comma. Okay, next, also a quadratic equation. First step would be to make sure that it's set to 0, so subtract 24 from both sides. From here, I could put it straight into the quadratic formula and solve it. On this particular problem, I happen to notice that all of the coefficients are nicely divisible by 3. I'll divide by a negative 3. That leaves positive x squared minus 6x plus 8 is equal to 0. Let's use the quadratic formula on this one. For review, that's opposite of b plus or minus square root of b squared minus 4ac all over 2a. And in this problem, a is 1, b is negative 6, and c is positive 8. So this would become x equals the opposite of, plug in negative 6 for b, plus or minus the square root of negative 6 squared minus 4 times a, which is 1, times c, which is 8, all over 2 times a. That's 6 plus or minus the square root of 4 all over 2. 6 plus or minus 2 over 2. Now I can separate that into two separate answers. X is either 6 plus 2 over 2, which would be 8 over 2, which would be 4, or x is 6 take away 2 over 2, which is 4 over 4, which is 1. So again, I got two different answers. In WebAssign, in the box to enter your answers, you would just put them in separated with a comma. Next, 1.3, take away 878.8x to the negative 2. Okay, how do you solve if it's a negative exponent? Because there's not a negative quadratic formula. Well, actually, we don't solve with the negative exponent. Instead, we use the exponent properties, as you recall, to take the negative 2 exponent would bring a positive 2 exponent down to the denominator. So x to the negative 2 is the same as dividing by x to the positive 2. So now I have 1.3. Take away 878.8 over x squared equal to 0. I need to solve for x squared, so first I'll subtract 1.3 from both sides. Negative 878.8 over x squared is negative 1.3. Okay, now to solve for x, I need to get it out of the denominator. I'll do that by multiplying both sides by x squared, and specifically it's x squared over 1. That will cancel the x squared off from the left-hand side in the denominator, but then you have to multiply the right-hand side by x squared also. Now I've got negative 878.8 is negative 1.3 x squared. Continuing to solve for x squared, I'll divide both sides by negative 1.3, which gives me 676 for x squared, and then square root, square root. Okay, now when you take the square root of both sides, you are responsible for the positive square root and also the negative, so make sure that you put that in. Then x will be either positive or negative 26. Again, there are two separate answers, a positive 26 or a negative 26. So you should be able to solve linear equations, quadratic equations, either by factoring or by the quadratic formula, either way. In our course, we will also be solving for x raised to the negative 2. Okay, now we need to talk about some business fundamentals. Cost, revenue, and profit. For a cost function, fixed cost per unit, variable cost, and the average cost per unit. So I have two kinds of variable costs and two kinds of per unit costs going on here. We'll start off with the total cost. Oh, and by the way, if in the homework it just says the cost function, it always means total cost. Total cost is variable costs plus fixed costs. Now, variable costs can be broken down to the cost per item times by the number of items, and then add on your fixed costs. Fixed costs is the overhead, the rent, or any other costs that are incurred even if you don't produce anything. So variable costs are the costs of the production, fixed costs are the overhead. So for example, if it costs $1.28 per unit and the rent and overhead is $450 of fixed costs, then the total cost function would be the variable cost per unit, that's $1.28, times by x for the number of units, plus $450. Okay, now here's another example. What if the variable cost per unit changed depending on how many units you made? Let's say it was 1/2 x plus 210. Then that 1/2 x plus 210 is acting like the $1.28. This is a per unit cost. So to create a total cost function, you need to treat that formula the same as you treated the constant of $1.28. It's the variable cost per unit times x plus, and then our fixed cost of $450. And then the x could distribute through. Our total cost function would be 1/2 x squared plus 210x plus 450. Okay, fixed cost per unit variable, and then total variable cost. Average cost per unit, we use this one quite a bit. The average cost per unit is defined to be the total cost divided by the number of units. The average cost function, we call it C bar, equals total cost is regular plain C, and then units is divided by X. We're going to use that quite a bit. You could work with this, like if you multiply both sides by an X, then the average cost per unit times by the number of units would equal the total cost. In fact, let's make this its own formula. Total cost is average cost per unit times by the number of units. So when we talk about cost, there are many different pieces to it. The cost is the total cost. Average cost is always a per unit cost. For the other types of cost, read your questions very carefully to figure out if it's a per unit variable cost or the total variable cost. Okay, next let's talk about revenue. Revenue is defined to be the price, specifically revenue is money coming into the business, so it's the selling price, the price the customer is paying, times the quantity, the number of units. Throughout the course, revenue will be a capital R, and then price is going to be a lowercase p, which I try to write a little bit different to signify that it's lowercase. And then quantity, sometimes WebAssign uses Q, many times it uses X. So revenue is price times quantity. Now, profit. Profit is total revenue, that's the money coming in, less the total cost, which is money that's going out. So you bring in your revenue, you pay your expenses, what's left over is the profit. Profit is a capital P, revenue take away cost. And this is the form that we'll use it in throughout the course. Let's do one example. We're going to do part of problem number 9 from the homework. Suppose that a company has fixed costs of $800, variable cost per unit of 15/16 x plus 1540. X is the total number of units produced. Suppose further that the selling price of the product is 1600 minus 1/16 x. Here's our question. Write the profit function. Profit is revenue less cost. Do we have a revenue function given? No. Okay, well then revenue is price times the number of units. Do we have that? Yes, the selling price is a formula for this problem. So the selling price, I'll plug in 1600 minus 1/16 x, and then that needs to be times by the units, which is also x. Now I've built the revenue function. Takeaway, do we have a cost function? No, we're given fixed costs and variable costs per unit. Okay, so cost is going to be per unit variable cost times the number of units, and then we have to add on the fixed costs. So revenue takeaway, variable cost per unit, that's 15/16 x plus 1540 times the number of units, and then add on the fixed costs of $800. Okay, let's simplify this, make it a little bit easier to work with. The x is going to distribute through. That'll be 1600x minus 1/16 x squared. Okay, over here I need to distribute this x through, so take away 15/16 x squared plus 1540x plus 800. And now this negative has to distribute through. So 1600x minus 1/16 x squared, take away 15/16 x squared, take away 1540x, take away 800. Last step, negative 1/16 x squared and negative 15/16. That would make negative 16/16, which is negative 1 whole x squared, positive 1600, negative 1540, positive 60x, and finally negative 800. That would be our profit function. Okay, go try the homework problems for this section. Remember that there are Canvas videos posted for these problems. Good luck!